today. This is kind of funny.
Spelled congratulations
Now I know.
wrong.
I know, exactly. Now I know how to irritate you. Okay, so this is going to be 2I plus 8 times negative 1, because I squared is negative 1, or negative 8 plus 2I,
Why
correct?
do you multiply it by I?
Well, I wanted to do an example of just how you can still multiply when it's a when you don't have both
You
components.
just treat it like it's a variable.
Right, except for from here to here.
Well, obviously.
Yeah, but okay, but now check out what happens. Negative 8 plus 2I is the point where you'd go 8 down the negative x number line. 1, 2, 3, 4, 5, 6, 7, 8. And 2 up. What slope would you follow to get to this point?
The opposite of that one.
Up here you'd go,
4.
rise over run would be 4 over 1. What would you get to get to net? Not quite opposite, not quite the right term.
Reciprocal.
Negative 1 over 4?
It's that's what Ramsey always says.
Inverse.
Well, no, it's not quite. It's and what would it be again, Kath?
Negative 1 over 4?
Negative 1 over 4. If one slope is 4
Opposite
over
reciprocal.
1, opposite reciprocal, which makes the, when the slopes are opposite reciprocals, what's true of the line?
They're perpendicular.
Perpendicular.
Damn it. Wow.
One of the actual uses of I in engineering is anytime you need to describe something that acts at a right angle in certain ways, you can throw I in and it can actually simplify the math. The only thing I ever worked on it was a college course briefly. I did some magnetic fields with electrical currents because the magnetic field goes up perpendicular to the wire in all directions. My father, as I've told you before, used I every day in working on submarine hulls because the water pressure is always perpendicular to the hull. This is nowhere near that complicated an example, but you can see how multiplying by I takes whatever you're talking about and rotates it 90 degrees in the imaginary plane. That can be a useful space in which to do certain types of math. Any questions on that real quick? Okay, so multiplying by I rotates your point 90 degrees, keeps it the same distance from the origin.
I like this.
This is so... Didn't you like it better when we were doing this in polar form a few months ago?
Oh god.
Cis, cosine plus I sine. Okay, now, division. This is the fun one. Now, I is only the first part today. I'm also going to talk about parabolas a bit. Next week, we may bring parabolas and I back together again, but it'll seem like two separate topics today. Division is the annoying one. If I do 5 plus 3i divided by 1 plus I, there is no straightforward way to do this. Division in complex numbers really just winds up being, how can I get the imaginary out of the denominator? It's more like rationalizing the denominator with radicals than it is like any sort of division or polynomial long division you've seen. So, there is a trick. If you use what's called a complex conjugate, does that sound familiar at all?
I'm sure you've heard it.
Complex.
No, I don't think we did.
Complex conjugate, I don't know if Mr. Singer got to that or not.
I don't think
Okay.
so.
Well, complex conjugate means pair. Okay, and what happens is a complex conjugate is a complex number that, when multiplied by another number, gets rid of the complexity. Here's what happens. If you have a plus bi, which is any complex number you can imagine, where a and b are any real number you can imagine, and you multiply it times a minus bi,
The eyes go away.
the i's wind up going away because, as you know, this is basically a plus b times a minus b gets you a squared minus b squared. This will always get you a squared minus bi squared, which is, what am I saying here? Oh, which is a squared minus b squared times I squared. I squared is negative 1, so this becomes a squared plus b squared. You guys remember your difference of square rule? A squared minus b squared gets you a plus b times a minus b. I always misspeak a little bit there. I don't mean to. I say there's no sum of squares rule. Well, there is a sum of squares rule. You can't split a squared plus b squared into anything real, but you can split it into a plus bi, a minus bi. This is a way to make i's go away and come back again. Do you want me to show the foiling here? Would that help?
No.
Because all the
You foil weird.
What?
I will track down
He just
Mrs.
didn't
Cayley,
do the
my
little-
8th grade math teacher, and I will tell her you said so.
You don't foil the way I foil now, just using my teeth.
But
Okay.
I don't know one way to foil.
Maybe you should do the middle step, like
Pardon?
the second step,
This one here?
like in between the first and second. The first and second.
Oh, that's what I meant. I'd have to foil and show the terms
Yeah.
disappearing.
Oh, I also noticed that in foil, instead of doing the outside
he
one
does,
first, you're doing the inside one
like,
first. So you technically are doing foil.
I was careful on the one I did here to do outside
yeah,
first,
yeah,
but
yeah.
sometimes I do
Yeah.
inside first.
Yeah.
Okay, the point being, if you have a plus bi, and you multiply it times a minus bi, the imaginaries will disappear,
Yes.
okay? I want the imaginary to disappear from the bottom, so I need to multiply the bottom of this fraction times 1 minus I. Am I allowed to just multiply the bottom of a fraction by anything I want? Well, yeah, actually I am, as long as very good. As long as I do the top as well. So the bottom of this fraction, well, here, the top is going to be 5 plus 3i times 1 plus I.
Wait,
And the bottom is going to be,
why did you change the sign?
1 minus I squared.
thank you, Janan.
I need my white out.
I changed the sign because I messed up. I was looking here. Okay. Now, on the bottom, bless you, I'm going to get 1 squared
Minus I squared.
minus I squared. Difference of squares reversed. Kind of impressed. On the bottom, I'm going to get 1 squared minus I squared, which is going to be 1 minus negative 1, so that'll become 1 plus 1. On the top, I'm now, Kath, going to carefully foil. I will do the outer first this time, just for you. So that's 5 times 1 first. Outer, 5 times minus 1, which is minus 5i, correct?
Correct.
Inner, which is plus 3i. And last, which is minus 3i squared. 1 minus I squared will become 2. Minus 5i plus 3i is going to be minus 2i. And this is going to become 5 plus 3, because that I squared will be negative 1. So that's going to be 8. And I can factor a 2 out of the top and the bottom, and that's
Cross it out.
4 minus I over 2. Apologize for scrunching this up a bit at the
Wait,
bottom.
wouldn't it be 4?
Yeah, I thought
Wouldn't it
you-
be 4 minus I?
I thought you just factored out the
Because you factored out.
Wow, that was 2 dumb mistakes in a row. I'm going to be so proud to put this one online. Thank you guys for catching that.
See, internet, we're smart.
That's right, you are. So this is just going to be 4 minus I. Thank you very much.
Touchdown.
Touchdown. Woo!
Sound like homework.
This is the most annoying one, the division. Okay? If you are dividing by a single term, well, if it's a real term, it's easy. You don't have to pull out the complex conjugate at all. If it's a single complex term, like negative I, you'd multiply by plus I, top and bottom. Okay? Any questions on adding, subtracting, multiplying, and dividing complex numbers that you're seeing? I hope for either the second or third time.
What if the I came? What if it was like I minus 1? Would you just say negative I minus?
Yes, I would change it to negative I plus 2.
Minus 1.
Thank you, whatever you said. Yeah, you put it in this order first, and then it will look, at least that's how it would look best to me, because I'm used to it. Yes?
This is like a really lame algebra question, but does difference of squares work if there's a number in front of the first? Like if it was 2, like 1 plus 2i, 1 minus 2i, is that still?
Yes,
Okay.
yes, it always works.
Okay.
Works forwards and backwards. In fact, you can, real quick, if I have 3x squared